Encapsulation is one of the important object-oriented programming features. The concept of encapsulation is all about how do you group up the data members and methods together as a single unit of the class and hide the implementation details of the same. So if you notice, there are two aspects in this. One is to group up the data members, that means fields to store the data, and methods to manipulate the same together. The second aspect is that hiding the implementation details. That means the code from outside the class should be able to access the fields indirectly only through methods, but not the fields directly. So we will focus more on this second aspect in the next lecture. But in this lecture, let us stick to the first aspect. That is data modularity. That means encapsulation encourages the developers to write a class that contains two types of members mainly, fields and methods. Fields are the data. For example, we have collected the details of a person, like person name, email, phone number, etc. And also, there can be some manipulations that are required to perform on this particular data. For example, storing or setting a value into the field, retrieving those details later while printing the values to the user, or for supplying the same details to other class, and also performing the validations, that means checking the values whether those are correct or not before storing them into the field. And also you may have some calculation logic. So to perform operations on the fields, you require to create methods. So you have the data in the form of fields, and you have operations in the form of methods. A class encapsulates, that means groups both together as a single unit. So this is the first part of the encapsulation. And also there is another aspect of encapsulation, that is to hide the implementation details. That means you will have to create the private fields with public methods. So it encourages the data integrity. That means the code that is present outside the class will be able to access the fields only through methods, but not directly. We will focus more on this data integrity in the next lecture. Let me explain the grouping of fields and methods together as a single unit with an example. In the existing application, we have already created a class called product with various fields. For each of the field, we can create two methods, that is set method and get method. The set method is used to assign a value into the field, but the get method is used to retrieve the value from the field. For example, if you want to set a value into the product ID, instead of assigning the value directly into the field, it is better to pass that value to a method, and inside the method, we assign the value into the field. In that way, methods let you to access the fields indirectly. This is the better way of programming in real-time projects. Because inside the method, we can write some code for validations or calculations which are necessary every time you access the particular field. And for each field, you can create two types of methods. One is set method and other one is get method. The get method simply returns the existing value of the field. If required, it is able to perform some calculations, such as calculating the tax based on the cost. So let's get started. First, we will take the field called product ID. And for this field, we are going to create two methods. One is set product ID and other one is get product ID. The set product ID method assigns a value into the field called product ID, and the method called get product ID returns the existing value of the product ID field. So creating a set method for product ID. Public void set product ID. The set method must be prefixed with the word called set, which means that we are going to set a value into the particular field. So which field is it? Product ID field. So overall it becomes set product ID. And it is better to use the Pascal case for all the methods in C#. So inside the set product ID method, we are going to receive a parameter from the calling portion. That means from the place where exactly you will call this method, you can pass a value as argument. That argument value will be received into this place. So here exactly you require to create a parameter. The parameter is nothing more than a local variable which is able to receive the value from the calling portion. So I am trying to accept the integer value and the parameter name is value. In fact, the parameter name can be anything. And you require to assign this value parameter into the field called product ID. Because the parameters are short-lived, they will be allocated when you exactly call the method, and parameters will be deleted at the end of the execution of the method. So parameters are very short-lived. They exist until the execution of the particular method in which they are declared. But fields are long-lived because they exist till end of the object, and generally objects are deleted at the end of the application. So this parameter will not be stored inside the object directly. The parameters are stored inside the stack. So that is the reason we have to copy the value from the parameter into the respective field, that is product ID in this case. So read the value from the parameter called value and assign the same into the field called product ID. So this is the set method for product ID field. You can follow the same syntax for all the subsequent set methods. Now we are going to create get method. Generally, the get method returns the value of the field. In this case, the product ID is of int type. So the return type of this method is int. And the method name is get product ID. So the naming convention for the get method is first create a prefix called get and then followed by the field name, that is product ID in this case. So if the field is product ID, then the method names will be set product ID and get product ID. And then return the current value of the field, that is return product ID. So it will read the value of the field and return the same to the calling portion where this method is called. So this is the overall look and feel of the set and get methods of the product ID field. We can repeat the same for product name and other fields. So we have a field called product name which is of string type. Creating set method for product name. And creating get method for product name. And we have a field called cost which is of double data type. So this is the get method for product name. And this is the set method for cost. And then this is the get method for cost. And then we have a field called tags which is of double type. So this is the set method for tags. And this is the get method for tags. Already we have created a method to calculate the tax based on the cost. And then we have a field called quantity in stock, which is of int type. So this is the set method for quantity in stock. And this is the get method for quantity in stock. And then we have a read-only field called a date of purchase. So for this field, we can create only the get method but not the set method, because we cannot modify the value of the read-only field except in the constructor. So this is the get method for a date of purchase. So overall, have a look at the complete code of the product class. These are the fields of the product class. This is the constructor that executes automatically every time when you create object for the product class. Set method for product ID. Get method for product ID. Set method for product name. Get method for product name. Set method for cost. And get method for cost. Set method for tax. Get method for tax. And calculate tax is a method that calculates tax based on the cost of the product. And this is the set method for quantity in stock. Get method for quantity in stock. And get method for date of purchase. So here we have implemented the encapsulation in such a way. We have declared the set of fields and corresponding manipulative methods in the same unit that is called product class. So whenever you create a set of fields and set of methods that manipulates those fields as a single unit, that concept is called as encapsulation. Now in the console application project, that is in the program.cs, we have to access the set method and get method instead of accessing the fields. So we have created the reference variables, we have created objects. So here instead of setting the value directly into the field, we are going to call the set product ID method and pass in the value as argument. So how this method gets executed? When you call the method, the execution sequence jumps to the particular method. So for this method, a separate stack will be created. In that stack, the parameter variable gets stored. And also, the parameter will receive the value that you pass while calling the method. In this case, it is 1001. So the value of 1001 will be received into the parameter that is value. And the same value that is 1001 will be assigned into the field that is product ID. So overall, by calling this method, you are initializing 1001 into the product ID. That is why we can say set method is used to assign a value into the field. For real-time programming, using the methods is a better way because inside the method we can add some logic for calculation or checking some conditions to validate the value before assigning into field. In the similar way, let us call the set methods of all the fields. So in this statement, which method should you call? That is set product name, right? So I am calling the set product name of the first product and passing a value that is mobile to the parameter called value. So this value called mobile will be received by the parameter called value in the set product name method. and the same value, that is mobile, will be assigned into the field called product name. In that way, overall, the set product name assigns a value into the field called product name. So exactly in the same way, we are calling set cost method of the product 1, and then set quantity in stock, set product ID, set product name, set cost, set product ID, set product name, set cost. So we have converted all the statements that assigns value into the field as methods. So overall, by calling the methods, we are setting into the fields of first object, we are initializing the fields of the second object, and we are initializing the fields of third object through the methods. And then we are calculating the tags based on the cost. And below, while printing the value of the field, instead of accessing the field directly, it is better to call the get method. So the get method returns the value of the field, and that value can be printed by using console.writeLine method. For example, you would like to print the product ID of the first object. So instead of accessing the field, we are calling the get product ID method of the first object, and from here the execution flow jumps to the get product ID method. So inside that method, we simply return the existing value of the product ID, that is 1001. So as we are returning the integer value, we specify the return type as int. So that value of the field, that is 1001, will be returned back to this place. And finally, that value will be concatenated with the product ID and then displayed by using writeLine statement. In that way, indirectly we are accessing the field through the methods, but not directly. This is a better and a recommended way of programming in object-oriented programming style, because the methods must be used to manipulate the fields. And then call in the get methods of all the fields of the first object. And also call in the get methods of second object. And then call in the get methods of third object. And also call in the get methods to calculate the total quantity. So overall, we have created the fields and the methods that manipulates those fields as a single unit called class. So this concept is called as encapsulation, and we have implemented the same in the product class.